All right, everybody, welcome to another IAEI News Live. My name is Thomas Dimitrovich, and this is a recorded session. I am traveling and I wanted to make sure that I did not miss Tuesday. So welcome to Tuesday. Welcome to IAEI News Live. Today, we're going to finish out services. I'm hoping to. So we're going to walk through a little bit about a little recap of what we talked about I think it's the last two sessions. And then we are going to finish it up, I think. Just walk through some more examples and explore services. We've got a few public comments out of our last two discussions. So let's talk services. IAEI News Live, and it all starts now. All right, welcome back. Okay, so we learned, at least I learned a lot last 2 weeks going through Article 230, and we bounce around a little bit because Article 230, if we're talking services, we just don't live in Article 230. We take a journey over to Article 250 for grounding and bonding. We'll move over to Article 110 for your general requirements. And when it comes to services, 110.16 comes to mind for arc flash labeling. Also, there will be some available fault current marking requirements, things like that. And obviously, we've got to apply all of our equipment adequately. So short circuit current ratings, 110.10, interrupting ratings, all that jazz. So what I wanted to do, though, is let's first talk a little bit about some of the changes that came out of the last two sessions. I have this change here that I submitted. That deals with fire pumps. 230.4a, special conditions. Additional services shall be permitted to supply the following. I'm removing optional standby systems, and that is because optional standby systems, Article 702, you can't have a utility be one of your optional standby systems. So that it didn't make sense to include that in the list. And then I removed interconnected electric power production sources because if it was interesting on that one. I went back to when that first went into the National Electrical Code. I believe it was the 1984 NEC. And the reason it was put in the first place was because they said that it was needed to permit photovoltaic, wind, or other electric power production sources to be installed in parallel with a utility. Well, those sources are not services, so it doesn't make sense that those would be, that would need to be in special conditions, because if you're going to have an additional service, it's not required when you are installing those other systems. And I'm pausing because I'm thinking about this one. Those would be service conductors. Okay, so an additional service, you've got to look at what the definition of what a service is. I had to go back and think about, does that make sense? The conductors and equipment connecting the serving utility to the wiring system of the premises served. So I have one service on a structure, and I don't necessarily, I don't need to pull another utility feed. I can connect to an existing service and so that's, at least that's my argument now. So that's one of my public inputs. Well, I'm thinking about whether or not that makes sense, but for now, I'm removing 5. All right, so I got 4 coming out and 5 coming out. So that was one change in Article 230. Another change that I believe makes sense is in 230.66. Now, let's take a look in 230.66 for the meter, for the utility meter, I have 230.66B as one of the sections. And what 230.66 is titled is marking, and B is meter sockets. And it says meter sockets shall not be considered service equipment, but shall be listed and rated for voltage and current rating of the service. There's no marking requirement in B. So I am proposing moving that language over to Chapter 4, specifically in 408. All right, and then the next change I have is in 230.82, equipment connected to the line side. Okay, so this came out of, I'll show you the application this came out of. This came out of this diagram right here. I had a phone call. And what the individual wanted to do was add this transfer switch to an existing installation. And what I'm showing right now on this, in this diagram, is what we ended up with. And what we ended up with was that we had a sort of a conflict. In 230.82, equipment connected to the supply side of a service disconnect. In item 5, I think it's 5. One, two, three, 4, 5. It said conductors used to supply energy management systems, circuits for standby power systems. And that's what this is. This is a standby power system. So what 5 says, conductors used to supply, and I'm just going to focus on the standby power system. Conductors used to supply standby power systems if provided with equipment, provided with service equipment and installed in accordance with requirements of service entrance conductors. So what that meant was that this had to be service equipment. Now, if this is service equipment, that means all of the grounding and bonding had to be done in that enclosure. And then that means that nothing downstream can bond the equipment grounding conductor, the EGC bar, with the neutral. right? Or the grounded conductor. So that bonding strap that is in between these two has to be removed. And what we walked away with was that when you're installing this in an existing installation, that bonding strap would have to be removed. And then what we realized, well, one of the things that I said, which was accurate, and I thought I made a mistake there, because, and I'll show you the text in the code that caused me to question what I had verbally said. And then I sort of changed my mind during that session, and it didn't sit right. So I called a few people, and I'll show you the text that's in the code and help you understand how the standards for the products are written. But this equipment is going to typically, most of the service panel boards that you see out in residential dwelling units, I'm not going to say all. I'm not going to give you a percentage. I don't know. I have no idea if it's a majority, a minority, if it's average. I don't know. I'm not going to go out on that limb unless I did some more homework. But that service equipment could be suitable only for use as service equipment. So that is suitable only for use as service equipment. SOUSE. Now, if it is suitable only for use as service equipment, that bonding is done from the manufacturer. In many cases, you can't undo it. Well, put it this way. In all cases, you should not undo it because it is suitable only for use as service equipment. If it was suitable for use as service equipment, and the word only isn't there, it's convertible. You can make it service equipment, or you can make it a standard feeder panel. But most of those, well, a very large number, all of the service equipment that I've seen, let's just put it that way, is suitable only for use as service equipment. Now, I think on the chat from last week, there were a couple comments that said that they have installed many service panel boards that the bonding it can be converted, so it would be SUSE rated. Suitable for use, not suitable only for use. So you'll have to check. Now, because of the language in 230.82.5 that basically says if you are going to supply these standby circuits for standby power systems, that it has to be service equipment. Then you're going to buy a transfer switch that's service rated. It could be suitable for use as service equipment. It could be suitable only for use as service equipment. But when you install it, you're going to have to bring the grounding electrode conductor, which goes to the grounding electrode system, to that equipment. The bonding will automatically be done, and I'm showing that bonding right there. That bonding would have to be done there. You would land your grounded conductor from the generator on that bar. You would land the grounded conductor from the utility on that bar. You would land the grounded conductor that goes to the load on that bar. And you would land the grounding electrode conductor. If the bonding strap is there, then you could land it on either the equipment grounding conductor bar or the neutral bar. Or you landed directly on the neutral bar. So you would have to have enough lugs. You would need 1, 2, 3, and then 4, total of 4 lugs to be able to handle the 3 neutrals and the EGC. or the 3 grounded conductors and the equipment grounding conductor, or the grounding electrode conductor, the GEC. And then obviously, because that neutral bar and the ground bar are bonded together, because it's service rated equipment, you're good to go. Okay, so now that's a lot to take in. Because if that existing panel board inside the house or outside the house, doesn't matter where it's at, if it's suitable only for use as service equipment, you're going to have to change the panel board out. If it can be converted, if you can undo the bond, then that's not a problem. Now, my issue was when I first was going down this road, my comment was going to be, you don't have to do all that, because all you need to do is make this transfer switch suitable for use as service equipment. So SUSE rated, suitable for use as service equipment. You could bond it and tie the grounding electrode to it, or you could leave this grounding electrode tied in with the actual service and leave the equipment, and this is still your main panel. And I was going to say leave this as a service disconnecting means, but you can't, because those are not service conductors. It would be feeder conductors. No matter what, those are always going to be feeder conductors. That would just be your main circuit breaker for the panel. No matter which way I look at it, it's complicated, isn't it? Because this will always be your service disconnecting means. That's always going to be your service disconnect, because that's the only disconnect that disconnects you from the utility. The conductors that are in this raceway are feeders. Period. There's no technical reason why this breaker that's in this panel board can't remain as your main breaker, and the bonding and grounding be done there, and this transfer switch circuit breaker still be SUSE rated. You could even bond it and ground it there. There's nothing in the code that says you can't ground and bond multiple times ahead of the service disconnect. But in this case, you are establishing a new service disconnect when you put this transfer switch in. That is now your service disconnecting means. So I'm going to stick with my last discussion point. It looks, if I'm following the NEC, then if I'm following the letter of the code, that is this breaker that's in this transfer switch. This breaker is the service disconnect. That's your service disconnecting means. There's no way around that. This is going to have to be service equipment. Now, one of the changes I was going to make, and I still have it in there, and again, all of this is fluid up until August 28th. Conductors used to supply energy management systems, circuits for standby power systems, fire pump equipment, and fire sprinkler alarms. If provided with, and what it said was service equipment, I was going to change that to say, if provided with the equipment listed as suitable for use as service equipment and installed in accordance with the requirements for service entrance conductors. So, because when it says, if provided with service equipment, you can't have service equipment on the line side of service equipment. They're both service equipment. So my issue is, how do we permit? What I would say you have to do is you would have to still call this your service disconnect. And this transfer switch would have to be erase. I know there's a way to get an eraser. This disconnect, and this is what I'm going for. Now, whether or not it makes sense, I don't know. What I'm trying to say is this is suitable for use as service equipment. All right. And this is not the service disconnect. That's what I'm shooting for. That this main panel board would still be your service disconnect. But that breaker that's in that transfer switch is a service disconnect because it disconnects service conductors. And the breaker that's in that downstream panel board is not a service disconnect because it is disconnecting feeder conductors, not service conductors. So I don't think where I wanted to go with that is doable. At least I don't know a way to make the language make sense. I know what I want. That is what I want in the language, but I'm not sure how to get language that would equate to that. So in any case, if I'm adding, if I'm doing this as a new construction, or if I'm adding to an existing, then this is basically how I would put that together. You would want to disconnect that, make sure that the panel board that's in the house is not service suitable only for use, and you have your transfer switch. That main breaker in that transfer switch is your service, now your service disconnect. It can also be your emergency disconnect if that's on the outside of the structure. And I have this, I have all of that equipment that's on the right-hand side on the outside. You would bring your grounding electrode to grounding electrode conductor and connect all your grounding electrode system to that piece of equipment. All right, so those were, and that was, I think, the last change in 230 that I made, or I'm suggesting, thinking about for comment phase. I've entered them as public comment. I've got two changes in Article 230. 230.4. Yep, 230.4, that's public comment 414. And then I have the public comment 808 on 230.66. Okay, so let's keep moving. Let's talk about the meter socket. Now, you know that in 230.66, we talked about that already, that the meter sockets can come into, now when I say meter socket, what I'm talking about is what's in this inside the enclosure. I'm not talking about metering equipment. I'm not talking about the enclosure. We're just talking the socket. And in 230.66, so in Article 230, you have 230.66b, which we said it's supposed to be a marking requirement, but it's not. It just tells you that it has to be listed and rated for the voltage and current of the service. And there is an exception that meter sockets supplied by and under the exclusive control of an electric utility are not required to be listed. So if that meter socket is under the exclusive control of the utility, the National Electrical Code doesn't even apply, and you don't even need that exception. But in any case, it's there for clarity. 230.85 and 82. So let's take a look at 230.82. 230.82 says this is equipment connection to the supply side of the service disconnect. And item number 2 on the list is meters and meter sockets. If all metal housings and service service enclosures are grounded in accordance with Article 250, Part 7, and bonded in accordance with Article 250, Part 5. So, and the meter disconnect. Now, the meter disconnect is separate from the meter. So the meter socket is mentioned in 230.82, parent 2. All right. Now, they also talk about a meter-mounted transfer switch. That's also permitted on the line side of the service disconnect. And we already talked about the change I was suggesting with item 5. I think it's listed item 5. Now, the other section, 230.85. 230.82. There is no 230. Wait a second. 230.85. We may have moved some things around. So let's take a look at 230. Yeah, 230.85 is the emergency disconnect. I'll tell you what we did in the 2026 code. We are going to require the service disconnecting means to be on the outside of the house. So, and the only reason I put this as a reference for meter sockets and their enclosures, believe is because of meter disconnect integral to the meter mounting equipment, not marked as suitable only for use as service equipment installed in accordance with 230.82. So that's why I put that in there. But when you are thinking about service equipment, and here's the other thing. In C 230.85 emergency disconnect. This is in the 2023 code. In 230.85 Charlie, it says that it's titled replacement. Now, what it says is where service equipment is replaced, all of the requirements of this section shall apply. Where service equipment is replaced. Now, if you're adding on to an existing installation and you put a transfer switch outside and it now becomes your service equipment, I would say you're probably meeting that requirement. And now, but if it's outside, well, even if it's inside, and you're putting the transfer switch in between the utility and that main panel board, which used to be your service panel board, now it's a feeder panel board, and you now have a new service equipment. So I would say you're replacing that service equipment with something new. a new service equipment which is a transfer switch. That's a, and then you're going to need to put a disconnect outside. Now, the good thing is, for you to do that, you're going to have to call the utility anyway and kill power to the structure from the utility. So you will have full reign. You'll be able to pull a new conductor from that meter down to a disconnect and then come into the house. And I would leave the conductor going into the house already and then just reconnect that to the new equipment that you're putting on the outside. And you just put a disconnect outside, period. I would not personally elect to say intentionally put if you weren't intending to put the transfer switch on the outside of the house to begin with, I'd tend to leave it on the inside of the house. Why? Well, I'd make the argument that that equipment is probably going to last longer if it's on the inside of the house. I know that the enclosure and everything is listed and rated for the outdoors, but I don't care what the equipment is. You put it in an air-conditioned or a controlled environment, it's going to do a lot better and last a lot longer than if you put it out and expose it to the extremes. Personal opinion on that one, that would be my advice. So in any case, now the exception to the replacement is where only meter sockets, service entrance conductors, or related raceways and fittings are replaced. The requirements of this section shall not apply. Honestly, if you're changing out a meter socket, if you're changing out the service entrance conductors, I mean, if you're changing the conductors out, I mean, that would be, I'm not sure I agree with the exception, but it's there. In your case, in the case of adding a transfer switch, you're changing equipment. You're taking what used to be the service and making it a feeder panel, and you're either doing that by undoing the bond because it's suitable for use as, not only as, and then adding new service equipment. So in any case, that's 230. So those are the requirements in 230. Let's take a look at 312. In 312, you got to think about this is your cabinets, cutout boxes, and meter socket enclosures. They specifically call out meter socket enclosures. And the sections that I could find that directly mention meter sockets are 312.5, 312.6, deflection of conductors, 312.100, and 312.102. Now, I would argue that many of the requirements that are in Article 312 are addressed when you get listed equipment. Now, remember, if it's not, it's required to be listed. If it's not listed and it's owned by the utility, none of these requirements apply to it anyway. So if it is service equipment, if it's a service meter socket, and it is not owned by the utility, it's required to be listed, it will be listed, and I would argue that when you get into the material, that's going to be a part of the listing. The fact that it has a door or a cover, it's going to be part of the listing. Now, when it comes to deflection of conductors and how they're installed, I can definitely see that being a part of the installation process. So this is your 312.5 cabinets, cutout boxes, protect cable assemblies and insulated conductors that enter the cabinets, cutout boxes, and meter socket enclosures from abrasion. Openings have to be closed, and metal cabinets and cutout boxes and meter. So again, you have to close all of those gaps and all those holes. Make sure we use approved identified solutions. You are probably going to come in on the top of that meter enclosure. That you can do that. You have to use listed components to get that done. The openings to be closed only applies to the conductors that enter in this 312.5A. Now, don't forget, 110.12A applies to all unused openings. So we cover our basis. We got the 312.5 requirement for any conductors where they enter, and then we have 110.12a, which requires any unused openings to be closed. It also speaks to the different types of plugs that you may use and the proper installation and application of those. So check out 110.12a. Hopefully you're not, there's going to be basically two holes in that piece of equipment. One where the utility service conductors come in, and the other to the meter, and the other where those service conductors leave the meter and go to your service disconnect or your transfer switch, whatever. And 312.5b, this is your metal. This applies to your messenger support. This is any of the conductors that are going to be affixed to the outside of that box. Or anything that enters through insulating. You have to enter through an insulated bushing, flexible tubing extended from the last and insulated support and firmly secured to the enclosure. So 312.5 in its entirety is going to apply to your application. Your cables have to be secure. Again, you're talking about service conductors here, so you're not going to be running other types of conductors through there. The utility's not going to let you anyway. 312.6, deflection of conductors. This is your width of your wire gutters. Now remember, the equipment is not just going to be a meter socket, right? Enclosure. This could be a meter center. It could be meter breakers. So you may have a meter in a side, and you might have a panel board in there as well. So don't just think of it as a meter. Think of this as many different types of scenarios. Conductors can't be deflected within a cabinet or a cutout box unless a gutter having a width in accordance with Table 312.6a is provided. Your conductors in parallel in accordance with 310.10g have to be judged on the basis of the number of conductors in parallel. You have to have good wiring. You have to adhere to the wire bending space rules at your terminals. You have conductors not entering and leaving an opposite wall, and then you have conductors entering or leaving an opposite wall. So follow all of those rules for when you're installing your conductors through that meter enclosure, which again may not just be a single meter in an enclosure. It could be multiple meters in a single enclosure. You may have a meter breaker, meter panel board, all that good stuff. There are special requirements for larger conductors as well. You have your 312.100. Now this, metal enclosures, that it's 0.053 inches uncoated steel, that's going to be a part of the standard. By listed product, which is required for this application, and this should be set. If it's not listed equipment, you can't permit it based upon the code. And if it's not listed because it belongs to the utility, then it doesn't fall under the purview of the code. Makes sense? All right. Just looking to see in 230, Article 230, they should have moved everything listing. It says all service equipment shall be listed or field evaluated. And when they do a field evaluation by a field evaluation body, they're going to mark it anyway. So all service equipment has to be listed. Now that is, again, which falls under the purview of the NEC. All right. 312.102, doors or covers not required to be a door, but it can be just a cover, like a bolt-on cover for the meter socket, etc. But remember, if it's listed, you're good to go. Can't forget about Article 110. Now, there are a lot of different requirements in Chapter 1. Remember, Chapters 1 through 4 apply generally. Now, in 110, you're going to have 110.10 will be the short circuit current rating. 110.24 is your available fault current marking. 110.16 is your arc flash label. And in 110.16, you'll just need a hazard marking, right? So remember, that's that generic marking that the hazard of electrical shock or burn, do not break or seal. That's your motherhood and apple pie label, I call it. That's your 110.16a. Now, 110.16b says, in other than dwelling units, in addition to the requirements in 110.16a, a permanent arc flash label has to be field or factory applied to service equipment and feeder supplied equipment not rated or rated 1,000 amps or more, and the arc flash label has to be in accordance. So, service equipment. That's service equipment. What is service equipment? MNOPQRS. Service equipment is defined as the necessary equipment consisting of a circuit breaker or switch and fuses and their accessories connecting to the serving utility and intended to constitute the main control and disconnect of the serving utility. So that would not be your meter. If you just had a single meter enclosure and then you came down to a panel board which was service equipment, and that had your main overcurrent device in it, your service overcurrent device, that's the equipment. You're not labeling the breaker itself. You're labeling the enclosure within which the circuit breaker is installed. I don't like the way that's written. It says the necessary equipment, which consists of a circuit breaker or a switch and fuse, and their accessories. Service equipment is not a circuit breaker. It's the equipment within which, every time I see something like this, I just go crazy with, it doesn't make sense. The language, well, you know what we're talking about. It's the enclosure, not the circuit breaker. So that's your 110.16. And also in 110, so you've got to, again, think about all the different areas. So all of 110 applies, right? You have your terminations, your electrical connections, 110.14 requirements, torque requirements. Your arc flash label for service equipment, not for the meter socket itself, but if your service equipment, if it's a meter breaker deal, then that piece of equipment will have to have that arc flash labeling. (110.20) identification of disconnecting means. 110.24 will be your available fault current. 110.26 is spaces about your electrical equipment. I mean, that's it's service equipment. You're going to need working space and the proper depths. That's if it's less than 1,000 volts. If it's greater than 1,000 volts, you're going to a different section. All of that it requires. 110.27, that's your live parts. 110.28, all your enclosure types. So you have to make sure that you have, you're using the right equipment for the application. If it's outdoors, if it's a 3R enclosure, if it's mounted on the wall, you're good. But remember, a 3R enclosure cannot be put on its back. You've got to think about what are the proper NEMA enclosure that you're putting out there for the environment. All right, so 110 is a smorgasbord of a lot of different requirements. Let's talk about 250. Now, this would be your grounding and bonding. And so, if you remember, yeah, this will do. So, in here, we've got the main bonding jumper, right? You have your grounding electrode conductor, and this is your grounding electrode, right? So where would we go? We would be going to 250 dot. So the main bonding jumper is 250.28. This is going to tell you the material that it can be made out of, the construction, the attachment, how to size the main bonding jumper. If you bought a listed equipment that is suitable for use as service equipment or suitable only for use as service equipment, those details are all taken care of for you. And service equipment is required to be listed. So I don't know that you would have to be thinking about the main bonding jumper in sizing for that equipment. Maybe you know where those details will come into play. You shouldn't be field fabricating anything like this out in the field. If the manufacturer forgot to include it, then call the manufacturer and have them send you the appropriate part for that application. This tells you if the main bonding jumper is a screw only, that the screw has to be identified with a green finish that shall be visible with the screw installed. And how you may see that, you wouldn't have, this would not be there, that bar. You would just have like a green bond, that screw that goes in this way. Now, if you had that and this was not there, that bar that physically connects the ground bar with this neutral bar, then you would have to, the grounding electrode conductor would have to land on that neutral bar. You can't use the back pan as your main bonding jumper. So your main bonding jumper has to be a wire, a bus, a screw, or similar suitable conductor. So I can't land my grounding electrode conductor on the ground bar. I can't move this over to here. I can't, if that was not there. Okay? So let me make a copy of this, duplicate. I'll show you what I mean, jelly bean. So in this application, if I deleted this, deleted that, and let's say, for example, that I came out of here and I'm going to make this thick and I'm going to color it green. All right. And I'm going to move this over top of that. Okay. And I'm going to draw a little circle to show it's bonded. And I will color that green as well. Give it a green outline. So let's say that we had just this. I would not be permitted to do that. All right, so, and the reason I could not land my grounding electrode conductor on this is because I am using the back pan to connect the neutral bar with the grounding electrode conductor. So if I don't have this bond, this main bonding jumper being a wire or one of those types of solutions, then I must land this conductor right there. Okay, it has to be on that neutral bar. So I would have the grounded conductor coming in from the service, landing on the neutral bar. I would have my grounding electrode conductor landing on the neutral bar. And this could be bonded to the back pan, which would give me my main bonding jumper. So this would be my main bonding jumper. Shapes. So that's my main bonding jumper. Let's make this thicker. All right, my grounding electrode conductor, my GEC. Grounding electrode conductor would be this conductor here, and it has to land on the neutral bar because I cannot use the back pan between my GEC and my neutral bar, my grounded bar. Again, unless I did this. Now I can do that. Give that a nice big one. So because that bar exists, that physical bar exists right here, let's go grab the text from the other. C, Control V. Okay, so this is still my grounding electrode conductor. My main bonding jumper is right there. So that's my main bonding jumper. And because it is a physical bar, it's not the back pan, I am permitted to land the grounding electrode conductor on this grounding bar, and not on the neutral bar. So that's, again, make sure everything is Kovacevic there. All right. It's like poetry in motion. It's beautiful. All right. Let's think. Where else? All right. So we've covered the ground Article 250. Let me just make sure I didn't miss anything in Article 250. 250.28 is your main bonding jumper. So 250.8. So if you look at 250.28 for the main bonding jumper, C, attachment, it tells you that equipment grounding conductors, grounding electrode conductors, and bonding jumpers shall be connected by one or more of the following means. You can use listed pressure connectors, terminal bars, pressure connectors, exothermic weld, etc. There's a nice little list of on what you can and cannot use for the attachment. So that is 250.28. Come back up in 250. Thought there was a 20. I think there's a 24. So 24 says, so 250.24 is your grounding of service supplied alternating current systems. And A is your system grounding connections. The grounding electrode conductor connection shall be made at any accessible point from the load end of the overhead service conductors, service drop underground service conductors, or service lateral to the terminal or bus to which the grounded service conductor is connected at the service disconnecting means. So the grounding electrode connection has to be to the terminal or bus to which the grounded service conductor is connected at the service disconnecting means. So that's right here. That is right here. Right? A grounded conductor shall not be connected to normally non-current carrying metal parts of equipment, to equipment grounding conductors, or be reconnected to ground on the load side of the service disconnecting means except as otherwise permitted in this article. That's load side, so you can't bond to the equipment grounding conductor on the load side of this of the service disconnecting means. So that's what we're saying. You can't bond again downstream. The main bonding jumper for grounded systems, an unspliced main bonding jumper shall be used to connect the equipment grounding conductors and the service disconnect enclosure to the grounded conductor within the enclosure for each service disconnect. So in accordance with 250.28, we already talked about 250.28. If an AC system operating 1,000 volts or less is grounded at any point, the grounded conductors shall be routed with the ungrounded conductors to each service disconnecting means and shall be connected to each service disconnecting means grounded conductor's terminal or bus. All right, that's what we're talking about right there. That is D. That is 250.24D. A main bonding jumper shall connect the grounded conductors to each service disconnecting means enclosure. Now, I can, as we said before, I can do that a couple different ways. I could just simply take and bond it there and lose the strap that's in between the two, right? If I wanted to do that, I could. A main bonding jumper shall connect the grounded conductors to each service disconnecting means enclosure. The grounded conductor shall be installed in accordance with 250.24D1 through 4. So D1 is the sizing for a single race wire cable. Conductors connected in parallel is 2. Delta connected services is 3. And then impedance grounded services is 4. In E 250.24E, a grounding electrode conductor shall be used to connect the equipment grounding conductors, the service equipment enclosures, and if the system is grounded, the grounded service conductor to the grounding electrodes required. So that's this. And by connecting it here, by having the main bonding jumper there, I'm achieving 250.24E. Grounding electrode conductor, this is my GEC, shall be used to connect the equipment grounding conductors. This is my EGCs, equipment grounding conductors. The service equipment enclosure, that's this. That's the enclosure. And remember, this is bonded to the enclosure because it's right up against the enclosure. And if the system is grounded, the grounded service conductor. So this is my grounded service conductor to the grounding electrodes. And this is my grounded electrode. Required by part 3 of the article. This conductor shall be sized so that this conductor shall be sized in accordance with 250.66. And then they give you a note about impedance grounded systems. And then F is the ungrounded system grounding connections. So 250.24 250.24 gives you all of the information about the main bonding jumper as a wire or a bus bar, and how to handle the bonding and what all has to be connected together inside that service equipment. All right. In 250.25, grounding of systems permitted to be connected on the supply side of the service disconnect. Grounding of systems. So the grounding of systems connected on the supply side of the service disconnect, in accordance with 230.82, that are in enclosures separate from the service equipment enclosure shall comply with 250.25A or B. If it's a grounded system, if the utility supply system is grounded, the grounding of systems permitted to be connected on the supply side of the service disconnect and are installed in one or more separate enclosures from the service equipment enclosures shall comply with the requirements of 250.24A through D and 250.24A through D. Premises-wise systems supplied by grounded AC services shall have a grounding electrode conductor connected. So you're permitted to connect and bond ahead of the service disconnecting means. All right. Okay, so what else in 250? 250.92 talks about a bonding of equipment for services. The normally non-current carrying metal parts of equipment indicated in the following. So all raceways, cables, cable trays, cable bus framework, auxiliary gutters, etc. To take a look at 250.92A, bonding of equipment for services. They all have to be bonded together. All enclosures containing service conductors, including meter fitting, boxes, and the like. So just think anything that's metal has to be all bonded together. maybe a little bit more light. Bonding jumpers meeting the requirements of this article shall be used around impaired connections, such as reducing washers or oversized concentric or eccentric knockouts. You want to make sure you have very good connections. Standard lock nuts or bushings shall not be the only means for bonding required by this section, but shall be permitted to be installed to make a mechanical connection of the raceway. So you can't use some of these connections as bonding for the service. Electrical continuity of the service equipment, service raceways, and service conductor enclosures shall be ensured by one or more of the following methods. Bonding equipment to the grounded service conductor by an applicable method, 250.8a. And 250.8a, that is, remember, we already talked about that. Listed pressure connectors, your terminal bars, exothermic, all that good stuff. Connections made up wrench tight using threaded couplings, threaded entries. Threadless couplings and connectors if made up tight for metal raceways. Other listed devices such as bonding type lock nuts, etc. So 250.92 services. Take a look at the bonding requirements. This is going to tell you what can and cannot be used when you're connecting all of these raceway together. The fittings here, whether you have what types of knockouts that you have. Typically we'll put that Myers hub type in there where you have the flat plate, right, like this, and then there's threads, and your conduit threads in that way. This is gasketed, and it's listed for a wet location because probably going to be on the outside of the house. All right, so you got to think about your bonding, how you're connecting your raceways, etc. That's 250.92. See what else is in here. I'm trying to think what else I might have. So in any case, let's take a look at what else what I didn't cover, because we have our service equipment. That's 230, Article 230, Part 5. You never would have thought that service equipment is this complicated, but it is. Part 5, at your service equipment enclosed or guarded, energized parts of service equipment shall be enclosed. Again, you're going to buy listed equipment. Barriers are going to have to be in place. Even if it's listed equipment, the barriers aren't going to be automatically installed. You're going to need to make sure those barriers are installed in your service equipment. But your marking requirements, and then your surge protection is 230.67. Don't forget the surge protective device and those requirements for surge protective devices. You're going to have to, now you may buy a piece of equipment where the surge device is like down here, installed over the bottom. And this is an SPD, and it's built right into the assembly. Keep these lead lengths. So keep, there we go. Discard changes. Keep these lead lengths short and straight. Keep those lead lengths short and straight. This has to be a 10K IN rating. So that is 230.67. And don't forget, please take a look at Articles 215 and 225 as well, because there are surge requirements over there on feeders as well. So you may run into a case where you have service equipment, and then you come down to your meter centers as feeder equipment, not service equipment, and those are going to have surge requirements as well. Please make sure you're buying and specifying the right products to meet the 10K IN requirement as well. And that's your 230.67. So we had, we talked about grounding and bonding. Talked about the service disconnect is Article 230, Part 6. Your disconnect means shall be provided to disconnect all ungrounded conductors. Service disconnecting means shall be installed in a readily accessible location. Don't put them in a bathroom. You can use remote control, but you make sure you follow the rules. You have to permanently mark it as a service disconnect, and it has to be any equipment that is suitable for use or suitable only for use. So this was, I'll tell you, this was my dilemma. Where is it? Anyway, yeah, service equipment. There was a section in here that said service equipment had to be marked as suitable for use as service equipment. And that is misleading. So in 230.66, it's in 230.66A, and this is what sort of threw me off last week. It says service equipment rated 1,000 volts or less shall be marked to identify it as being suitable for use as service equipment. So I talked to a few people, and I looked at the standard. I can make equipment 1,000 volts or less. I can make a dwelling unit panel board and mark it suitable only for use as service equipment. So arguably, you got to be careful how you read this, because the way I read it was if it's being marked as suitable for use as service equipment, then that sort of implies that it is convertible. But the way this is intended to be read is that if you have equipment that is suitable only for use as service equipment, it too is suitable for use as service equipment. It's not that it has to be marked as, it doesn't have to be marked suitable for use as service equipment. It has to be marked to identify that it is suitable for use as service equipment. So there's a very important little detail to understand in that language. So you can have service equipment 1,000 volts or less that is suitable for use only as service equipment and marked as such. Or you can buy it where it is suitable for use as service equipment, marked as such. So just be a little careful in that. When I first read that, it contradicted what I know. And I was like, well, it is what it says. But you got to really be careful. You have to really be careful when you read the language of the code. That is the value of IAEI membership. You can network, talk to individuals that you meet, you get their contact information, you build your Rolodex, and when you come across language like this that doesn't seem to make sense, you can make some phone calls. If you can add clarity in a public input. And sometimes if your interpretation of this based on how it's read, if you put a public input or a public comment in and it's rejected, that's not a bad thing. The panel statement on the reason why it's been rejected could be your evidence of the proper interpretation of that code language. All right, so I believe we talked about surge, we talked about barriers, 230.62. Don't forget to put those on. Line side of the service disconnect. We talked. I think we went through service equipment part 5. Yeah, we did. Service conductors. We really didn't go through all of the different requirements on service conductors. That is now. They're going to have to be protected and guarded. And when you get into service conductors, you get into the whole discussion of how do you size those service conductors. That I might just leave that for a different day and a different adventure here on IAEI News Live. Thank you for joining in. I hope you got something out of this discussion. I know I did. Every time I read through the National Electrical Code and I read the words, even after I go back and think I absolutely know exactly what this is saying, and you read it again, you say, okay, based upon some discussions, I don't think I need to change that language. I think it's okay. I think it's okay as it is. But you saw my journey on, especially on 230.66a. I was thinking, my original interpretation last week, nope, wasn't good. Made some phone calls, asked some questions, read through the standard a little bit. Now, the bad thing is I'm fitting the language to meet my research. We shouldn't have to do that with the code. So there might be a better way to say it in 230.66 marking requirements A. But I'm going to have to rewrite that anyway because I'm moving out meter sockets over to 408 and A goes away general, and now 230.66 will just be a marking requirement for service equipment rated 1,000 volts or less. Maybe as part of that marking, as part of that change, you never know, we might be able to add some clarity. All right, everybody, thank you for joining in today. I hope you got something out of it. I know I did, and I appreciate you, the dialogue. Hopefully you were making comments. I wish I could have been live today. I'm actually representing IAEI at an event in Costa Rica as we expand our presence to south of the border, to Central America, as we build our relationships with industry partners in other parts of the globe to bring electrical safety and knowledge to the industry. Hopefully, we can all save lives together. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe and please stay healthy. We will see you next week. Signing off for now, Thomas Dimitrovich. Take care, everybody.